Five types of pair of angles, if you can recall, are complementary angles, supplementary angles, linear pair of angles, vertically opposite angles, and adjacent angles. By now, I think you all know the meaning of each pair of angles. Okay? So before we move on with the lesson, in the last class, I had given you homework from page 102, exercise 5.1. The first 6 or 7 mains I had given, and I had sent the answers also. I hope all of you have checked the answers and corrected if you have any doubt. Okay, now I'll continue with the exercise from the next main, that is from 9th main, and then move on with the lesson. So in this main, in this figure, you can see two intersecting lines and one ray which is starting from O. So there are two lines, intersecting lines. They are, can you identify? They are AB and DC, line DC. Okay, so they are intersecting at point O, and from the same point O, the ray OC is emerging. Now your question is angle 1 adjacent to angle 2? Where is angle 1? This is angle 1. Where is angle 2? This is angle 2. Yes, they are adjacent because O is common vertex to both these angles and OC is the common ray. So, yes, they are adjacent. This is true. Is AOC, angle AOC adjacent to angle AOE? Which is angle AOC? Again, this is angle AOC. And he is asking if angle AOE, that is this entire angle, if these two are adjacent. Children, they are not, because even though they have the same vertex O, they do not have a common arm. They do not share a common ray. So, this is no. Do COE, angle COE and angle EOD form a linear pair? Now, let's see where they are. Now, you can see angle COE is this, okay, and angle EOD is this one. So yes, they form a linear pair because they are sitting on a straight line DC. Did you understand, children? Yes, they form a linear pair. What about angle BOD and angle DOA? Where is angle BOD? Let's do it with a different color so that you will know the difference. Angle BOD is here, children, and angle DOA is here. He is asking if they are supplementary. Yes, they are supplementary again because together this angle and this angle, the sum is 180 degrees. Yes, they form a supplementary pair of angles. Okay. Now, is angle 1 vertically opposite to angle 4? He is asking. Let's see. He is asking if, let me erase this, you will understand. Now, the question is angle 1, this is angle 1 and this is angle 4. These two are vertically opposite. That's the question. Is angle 1 vertically opposite to angle 4? Yes, they are. The next question is, what is the vertically opposite angle of 5? Angle 5. Angle 5, as you all can see, is here. Angle 5 is here. Opposite to that, there is not one single angle. It's been divided into 2 and 3. So when we are writing the answers, we will write angle 5 equals angle 2 plus angle 3, children. Okay, so 2 and 3 together is vertically opposite to angle phi. These two are vertically opposite angles. Okay. Now, let's see the answers. Yes, first case, yes they are. I told you what the reason is. The second case, no, because AOC and AOE, though they have a common vertex, they don't have a common arm. Third one is they form a linear pair. So the answer is yes. Fourth one, they are supplementary. Again, the answer is yes. And angle 1 is vertically opposite to angle 4. And then the last one, angle 5 is vertically opposite to angle 2 plus angle 3. Okay, children. Let's see the next main. In the figure, indicate which pairs of angles are vertically opposite angles. So the figure is this. Two intersecting lines again and one ray emerging from the common meeting point, intersecting point. So you have angle 1, 2, 3, 4 and 5. So the question is, how many pairs of vertically opposite angles are there? Okay, now let's see. Again, you can see angle 1 and 4 vertically opposite, children. This is angle 1, this is angle 4. Okay, so they are vertically opposite. Again, you have angle 5 and the whole thing, that is angle 2 plus 3, they form a vertically opposite angle pair. Okay, that's all. We do not have any more vertically opposite angles. Then what about linear pair of angles? So for linear pair, let me show you. Linear pair, we have angle 4 and angle 5. They are sitting on a straight line, as you all can see. So angle 4 and 5 form a linear pair, that is they are adjacent supplementary angles, so they have a special name as linear pair and the total is 180 degrees. What is the other linear pair of angles here? We have angle 5 and angle 1. Okay, so again they form a vertically opposite angle. Linear pair of angles, because together they have the sum as 180 degrees. Okay, let's see what the answer is. So angle 1 and 4 form a vertically opposite pair of angles, and angle 5 together with angle 2 plus 3 form a vertically pair. That is, one thing I hope you're all noticing, this angle and this angle, they are vertically opposite angles, but they are acute angles. So if one pair is acute, the other pair, that is this and this, they are obtuse. Okay, so on a linear pair, if one is acute, the other angle is obtuse, and if one angle is 90 degrees, the other angle will be 90 degrees. Please keep this in mind, children. Next one, linear pair, as we discussed, you have 4 and 5 and you have 5 and 1, angle 5 and angle 1. That is the next pair of linear angles. Okay, now please check this. By now I think you're all thorough with the definitions for all the pair of angles. So two complementary angles measure up to 90 degrees. That means when you add two complementary angles, the measure should be 90 degrees. Okay, sum should be 90 degrees. Then two supplementary angles, the sum should be 180 degrees. That is a condition. They can be adjacent or they don't have to be adjacent. If they are adjacent, then such supplementary angles are called linear pair of angles. Okay, then two adjacent angles have common vertex, children, and common arm. You know what an arm is? It is a ray. Okay, then linear pair, so they are not only adjacent, they are supplementary too. So total will be 180 degrees. Linear means straight, so they are situated on a straight line. I hope that's clear. Next, main. In the next main, in the given figure, angle 1 and angle 2 are mentioned. So you have to think and tell if they are adjacent pair of angles. So where is the angle 1? Angle 1 is there and angle 2 is here. So what do you think is the answer? Are angle 1 and angle 2 adjacent? That is the question. Are they adjacent? Now think, what is the condition required for adjacent pair of angles? They should have a common vertex and a common arm. As you all can see, angle 1 has vertex here and angle 2 has vertex here. So, though they have a common arm, they do not have a common vertex. So, these two angles, that is angle 1 and angle 2, they do not form adjacent angles. Children, I hope that's clear. So, let's see what the answer is. In the given figure, angles 1 and 2 are not adjacent because they do not have a common arm. Clear? Next main. Find the values of angles x, y and z in each case of the following figures. Children, you can all see we have these two. Now I think all of you can identify this line and this line. You can even name them as line AB and line CD for your reference. So line AB and CD are straight lines intersecting at, let's say, point O. Okay, this is the intersecting point. Okay, now, so as you all can see, and if you can recall, when two intersecting lines meet at a point, two pairs of vertically opposite angles are formed, is it not? So here he has given one angle as 55 degrees. Now can you guess what this angle is, children? Because we have defined last time, a pair of vertically opposite angles are always equal. So x should always also be 55 degrees. Do you agree? Yes, these two are vertically opposite angles. So x is also 55 degrees. Okay. Now what about y? Now x is lying on a straight line. Okay. So this and this form a linear pair, or even this and this form a linear pair. So if one angle is acute, as we discussed, the other angle on a straight line should be obtuse. So y should be obtuse. Okay. So can you tell me what the difference between these two angles is? That is, you have to subtract from 180 degrees, is it not? Because this entire angle is 180 degrees. So 180 minus 55 degrees, children. Can you tell me how much that is? Yes, please. Think and tell me. It is 125 degrees. When you sum it up, 5 plus 5 is 0, 7 plus 1, 8 and 1. I hope that's clear. So if y is 125, the opposite, vertically opposite it is of that angle is z. So again this should be 125 degrees. And the total at that point, that is the complete angle, will be 360 degrees. I hope this is clear. So sometimes we'll ask you what is the measure of angle x. Okay, in the test or exams, you may get questions like this. What is the measure of angle x? And if you say 55 degrees, you will be asked to state the reason why this is 55 degrees. So what do you say in that case? You will say it is vertically opposite to this angle AOC. X is vertically opposite to, angle X is vertically opposite to angle AOC. That is why it is 55 degrees, because vertically opposite angles are equal. Okay, children? Yeah. Next one. Here you have again two intersecting lines and then one emerging ray from the same point. So if this angle is 40 degrees, okay, if this angle is 40 degrees, what is the measure of, immediately you can find angle x also, because on this line you have 1, 2, 3 angles. Okay, out of the 3 angles, 2 you have, that is 65 degrees you have. The remaining is 180 degrees minus 65. Is it not? So what is the measure of angle x? It is 511. That is 115 degrees. That is one way of finding. Otherwise, opposite to this angle is angle Z. So Z also should be 40 degrees. If Z is 40 degrees, then what will be Y? It is 140 degrees, children. I really hope this is clear to you. There are many ways of finding the value of the given angles, because you know what the angles are now and you can give any reason, but the reason should be apt to that. Clear? Let's move on. So we found out angle Z is 40 degrees. Angle Z is 40 degrees. Angle X is 115 degrees. And angle Y is 140 degrees. Okay? Okay. Let's go to the next main. The next main is fill in the blanks in all these cases. Let's see what the blanks are. Read quickly and try to answer, children. If 2 angles are complementary, their sum is, yes, it is 90 degrees. It's clear? If 2 angles are supplementary, then their sum is 180 degrees. By now you should be able to quickly recall. 2 angles forming a linear pair are supplementary. Clear? They are supplementary. Then, if 2 adjacent angles are supplementary, they form a linear pair. I think all these are now clear to you. If 2 lines intersect at a point, then 2 pairs of vertically opposite angles are formed. A pair of vertically opposite angles are always equal. I hope you are following. When 2 lines intersect at a point, if one pair of vertically opposite angles is acute, the other should be obtuse. That's what we discussed, is it not? The angle formed at the point of intersection of 2 straight lines is equal to 360 degrees. It's a complete angle. Is that clear? Next. Now you have 2 intersecting lines and one perpendicular. So the lines are AC and BD and OE is perpendicular. So the question is, obtuse vertically opposite angles you have to point out, adjacent complementary angles, equal supplementary angles. Okay? Let's see the answers. So obtuse vertically opposite angles are angle AOD and angle BOC. Angle AOC and angle BOD, children. Adjacent complementary angles are this and this, because this is a right angle. So the other angle also should be right angles, but there are 2 angles here. They are adjacent complementary angles. So we'll name them as angle AOB and angle AOE. I hope this is clear. Equal supplementary angles. Which are the equal supplementary angles again? They are angle BOE and this angle BOE and angle EOD. Next, unequal supplementary angles, there are many. So you can name one of them as this and this. That is angle DOC and angle BOC. I hope that's clear. Now adjacent angles that do not form a linear pair. Yes, there are adjacent angles which are not forming a linear pair. There are many. So you can have here, there is one here, angle EOD, I'm talking about this angle and angle DOC. Angle DOC. They form adjacent angles, but they do not form a linear pair. Okay, children? Next. Pair of lines. Now, two lines L and M are called intersecting lines if they have a common point, and that common point is called point of intersection. So, if you can recall, the roads like 15th cross and 6th main, they meet at a point, is it not? So, they meet like, suppose this is 15th cross, then 6th main will be like this. I think all of you know this. So, this is called point of intersection, and these two lines are called, roads are called intersecting roads. Okay, so let's see. Two lines that intersect at a point, you can see this is the point of intersection. So these two lines are called this line and this line. You can even label them as PQ and RS. Okay, so they are called intersecting lines. You can see one more figure. Two roads intersecting at a common point. So these are examples for intersecting lines, and all of you have learnt in the last class that intersecting lines form vertically opposite angles. Two pairs are there. So this is one pair and this is the other pair. Okay. Next. The next pair of lines that we are going to learn is parallel lines. You're all familiar with what the definition is. What are parallel lines? Two lines are said to be parallel to each other if they do not intersect each other even when extended indefinitely. You remember opposite side of your blackboard, or let us say your ruler. This is one side and this is one side, and these are parallel. We show with arrows. So even if you extend them like this indefinitely, they do not intersect or meet. Such lines are called parallel lines, and this width, children, this width is the same throughout. Last year in 6th standard you have even constructed parallel lines using set squares and even protractor, if you can recall. Okay, so these are parallel lines. In other words, the distance between two parallel lines is constant throughout. Okay, let's see some examples. You can see this, these are vertical parallel lines, oblique parallel lines, horizontal parallel lines. So they need not be always horizontal, they can be in any different direction. Okay, even your windowsill, you can see horizontal parallel lines and even vertical parallel lines, is it not? You have seen in your classroom or in your window at home. Then you can see this is a track, is it not? Running track. The lines you can all see here, all these lines are parallel to one another, is it not? If they are not parallel, what will happen? If the runner starts moving, if they are not parallel, what happens? After a certain point, if the lines intersect, even the athletes have to, they can collide with each other. So definitely these are parallel lines. Okay, next. Parallel lines, lines that are always same distance apart and will never meet. You can see many more examples here. Hope it's clear. Okay. Next, non-parallel lines. Children, can you think what is the opposite of parallel lines? It is non-parallel lines. That means if parallel lines never meet each other even when you extend, non-parallel lines will definitely meet each other when you extend. That's the difference between parallel and non-parallel lines, and also the distance between them is not constant. Okay, that's why they meet after a certain point. Two or more lines which meet each other at some point are called non-parallel lines. The distance between two non-parallel lines is not constant throughout. You can see. See, after a certain point, when you extend, they are meeting. I hope you can see this. Yes, now they are not intersecting, but when you are extending, they are intersecting at a point T. Okay, at this point, they are intersecting. I hope you can see that. Yeah. So these are non-parallel lines. Here also you can see, in fact, you have, these are parallel lines, but this line and this line are not parallel, so they are meeting at this point X. Clear, children? Parallel lines are there and non-parallel lines are also there in this figure. You can see the difference. Okay. Next, transversal. Children, all of you know what a transversal is. Last year we have defined. Now in your book, in your exercise, in your classwork, if you have these ruled lines, ruled book, then all of you know what this line is. What is this line? It's the margin, is it not? This margin which cuts many lines at a single point. Each line is cut by one point, children. This line is called transversal. Okay, this is called a transversal line. Let's see how to define. The line that intersects two or more lines at distinct points. What do you mean by distinct points? Means specific, clear points. Such lines are called transversal lines. To two parallel or non-parallel lines, a transversal cuts each line at a single point only. That's what I showed you just now. Okay. Now, can you see? Can you see which are the lines and which is the transversal? So these, if you name them as L and M, L is parallel to M, children, and this is the transversal. Here, L and M are not parallel. They are not parallel to each other, but this is the transversal. Let us call it T. Okay. In both cases, it's cutting each line at a single distinct point. So when a transversal cuts two lines, then angles are formed. That's what we are going to learn next. Okay. Pay attention, children. Any number of transversal lines can be drawn to parallel or non-parallel lines. That means, what we mean is, we can draw one more transversal. We can draw one more transversal. Any number of transversals you can draw on two lines. I hope that's clear. Okay. Next, a margin of a rule sheet. These are the examples. You can see vertical parallel lines are there, and those lines are cut by a transversal. You can see like a diagonal. So each line it's cutting at a single point. There is a gate here, or a picket gate also it's called. Horizontal lines, and you can see many transversal. All these are transversal. This is one transversal, this is one, this is one, this is one. All these are transversals. So like I said, any number of transversals can be drawn. Now, angles formed by a transversal. Now you all know what parallel and non-parallel lines are and what a transversal line is. So when a transversal line cuts parallel or non-parallel lines, children, then 8 angles are formed. These are parallel lines and this is the transversal. It's named as L here already. So we'll keep it as that. So what are the 8 angles? All of you can see the 8 angles. Here there is 1, 2, 3, 4, 5, 6, 7, 8. Similarly, these are non-parallel lines and this is the transversal. Again you have 8 angles in the figure. Now, in these 8 angles, we have 4 interior angles. This region is interior. Okay? This region is interior and this is exterior. Is it not? In both the cases. Now, let us see. All these angles have specific name. Let us see what they are. So, in this class, we will be learning again these angles, name of the angles that are formed when a transversal cuts parallel or non-parallel lines. Okay. Now, interior and exterior angles. When a transversal cuts 2 parallel or non-parallel lines, 4 interior and 4 exterior angles are formed. You can see that is the interior part, interior region. So, DC, Y are interior angles. Please children listen carefully, and we'll see what the exterior angles are. A, B, Z, Y are exterior angles. Please bear in mind, these angles, that is DC, XY, are lying within the parallel lines or non-parallel lines. Here in this case they are parallel lines. You can even show the arrows to depict that they are parallel lines. Otherwise we don't take it for granted. It will be mentioned in the problem or it will be shown in the figure. Okay, so between the lines is interior, outside the lines is exterior. I hope this is clear. Okay, now let us see what the names of these angles are. The first one, various types of angles are formed and they all have special names. They are 4 pairs of corresponding angles, 4 pairs of alternate angles, 2 pairs of alternate interior angles, 2 pairs of alternate exterior angles, and 2 pairs of co-interior or consecutive angles. These are called consecutive angles. They are also called allied pair, but we'll use the name co-interior or consecutive angles. Now let us see what each pair is. Now, corresponding angles. Corresponding angles lie on the same side of the transversal. That means if these are lines and this is a transversal, they lie on the same side of the transversal and they are lying either on above or they lie below, like this. These are corresponding. What did we discuss? There are 4 pairs. So 1, this and this, they form corresponding. Again this and this and this. Okay, so let us see what they are. Corresponding angles. You can see in the figure A and B. You have A and you have B. They are lying on the same side of the transversal and both are above the lines. So such lines are called, such angles are called corresponding angles. Like we discussed, there are 4 pairs. One I've shown. One more is this and this. The next one is this and this angle, and one more is let us show with 2 ticks. One is here and one is here. That is this and this angle. Okay children, I hope that is clear what corresponding angles are. They are lying on the same side of the transversal and both will be either above the lines or below the lines. Okay, you can see here in this figure it's very clear. Red and red corresponding angles, green corresponding, yellow corresponding, again blue and blue corresponding angles. Observe carefully. Okay, let's move on. The next pair of angles are alternate angles. Alternate angles will lie, listen carefully, alternate angles will lie one on one side of the transversal, the other will be on the other side, opposite sides. Okay, both can be either interior or both can be outside. So we have 2 pairs, 4 pairs together. Out of the 2 will be inside, that is inside, and 2 pairs will be outside, that is here. Okay, so let us see what they are. Alternate interior angles are on opposite sides of the transversal and they lie between the 2 lines because they are interior, but they will lie on either side of the transversal children, unlike corresponding angles. So you can see here one is on one side of the transversal, the other one is on the other side, opposite sides, but they are interior. So there is 1 and 1. Can you identify the other pair of alternate angles, interior alternate angles? Yes, that is this and this. Clear children? 2 pairs. Okay. alternate interior angles. I have shown one as 1 and 2, the other one you can see with red. Clear? Interior angles, alternate angles. Okay? Alternate exterior angles, I'll come to that in the next part. Alternate exterior angles will lie outside the lines, not within the lines. They will lie outside but on opposite side of the transversal. Okay, alternate exterior angles are on opposite side of the transversal, lie above and below the two lines. That is, they are outside the lines, not within the two lines. Okay, so you can see, I can explain it to you. See children, one is here, the other one is here. They are exterior. Which is the other pair? Let me show you with other color. There is one more here and one more here. I hope that's clear to you. They are alternate exterior angles. You can see 1 and 2, 1 and 2. They are outside and opposite of the transversal. They are outside and opposite. Which is the other pair? The other pair is angle A and angle B. Okay. Co-interior angles or consecutive angles, children. Let me define what they are. Two pairs of co-interior angles are formed on the same side of the transversal and within the two lines. Okay. Let me explain to you. They are on the same side and within. So these two are called co-interior angles. That is this angle and this. How many are there? This is one pair. We have one more here. Okay. This is one more. This is the second pair of co-interior angles. How are they? They are on the same side of the transversal, but they are within the two lines. These pair of angles are called co-interior. So there are two pairs. One pair I have shown here. The other pair is here. Okay. That is, they are called consecutive angles or co-interior angles. You can see 4 and 6. 4 and 6. We have 4 and 6 and 3 and 5. Angle 3, angle 5, angle 4, angle 6. They form consecutive pair. I hope it's clear. Now, your activity. Identify the following angle pairs that are shaded. This is your activity for your homework, children. You can easily identify them. I think all of you know how now. It's very, very clear. This is alternate exterior angles. Very clear, is it not? Alternate interior angles. Here you have C and B as alternate interior and A and D as alternate interior angles. And again this is alternate interior angles. And here these are A and B are corresponding angles. Okay. So that is your activity. Please draw the figures and do it in your homework books. Draw a pair of parallel lines and a transversal in each case and shade the following pairs of angles. So in each case you have to draw parallel lines like this. And you have to shade corresponding angles. Any one pair. Now you know 4 pairs are there corresponding. You can shade any one pair. Let me show you. I am shading this and this. You can shade any one pair. Okay, children? Then, alternate interior angles. Shade any one pair of alternating interior angles. Shade co-interior angles. I think you know the difference between co-interior angles and alternate interior angles. Then linear pair of angles. This is linear pair of angles. Okay, so I can explain to you, okay, so that it will be easy for your homework. Alternate interior angles, let me show you one pair. Alternate means on either side, remember, interior. So I have shown you one pair of alternate interior angles. You have to only shade, you don't have to label them also. If you are asked to label, you can give them any labeling like angle A, angle B, anything you can give. Okay, so I think you can draw the other pair of alternate interior angles. Next one is co-interior angles, children. I'm showing you one pair. Co-interior means same side of the transversal and within the lines. I've shown one pair. You can show the other. Vertically opposite angles. Let me show you vertically opposite. Many are there. You can see how many pairs are there. 4 pairs are there. I'm showing you one. I have one here and one here. Likewise, you have 3 more pairs. You can identify now because you have listened to the lesson carefully. Once again, go through the lesson video, and I'm sending the PDF also. Read twice, thrice, and then do your homework. Again, linear pair of angles, you have many. That is again 4. In fact, you have 4 pairs in each point. Okay, that means 8 pairs. There is one and there is one here. I marked one pair of linear pair of angles. Okay, linear pair of angles. Okay, children, linear pair of angles. Okay, so I've shown you how to do your homework. I hope this is clear.